Hey everyone, and welcome to The Explainer. If you're gearing up for an exam or, just want to genuinely master the mechanics of our planet, you are in the exact right place. Today we're doing a highly structured crash course. It's designed to give you a complete, top-to-bottom understanding of environmental studies. We're going to map out exactly how our natural world operates, how human actions disrupt it, and the systems we use to try and fix it.
To do this efficiently, we'll follow a strict mental map. First, the foundations of our environment. Second, our vital natural resources. Third, the human disruption. Fourth, environmental ethics and equity. Fifth, policies for protection. And finally, number 6, the path to sustainability.
Section 1. Foundations of our environment. Okay, let's dive right into this. Before we can understand how to save the environment, we got to define what it actually is, right? So here's a crucial anchor point for your notes: an ecosystem. It's a functional unit where biotic, meaning living components like plants and animals, interact with abiotic, or non-living components like light, temperature, and atmospheric gases. They rely entirely on one another to survive. It's honestly like the ultimate team project where absolutely nobody can afford to slack off.
Now, historically, how we view our place in this massive system has completely shifted. On one hand, you have environmental determinism. This is that older view, arguing that nature strictly controls human life and development. But contrast that with the modern ecological approach, which is environmentalism. This paradigm understands that humans are an integral part of nature, and because we have such a massive impact, we require highly restrained, responsible resource use.
Which brings us to Section 2, our vital natural resources. The foundational ecosystems we just defined, they are fueled entirely by natural resources. And for your exams, you absolutely need to know the stark difference between the two main types. Renewable resources, like forests, water, and wildlife, regenerate naturally over time. Non-renewable resources, like land, topsoil, and fossil fuels, take thousands or even millions of years to form. Once you burn a lump of coal or wash away topsoil, it's effectively lost to us forever. You can't exactly put the smoke back into the coal.
And this perfectly frames a resource we take for granted every single day: water. When you look at the breakdown of global fresh water, it's actually pretty shocking how little liquid water is accessible to us. 80% is completely locked up, frozen in ice and snow. Another 19.7% is deep groundwater. That leaves a measly 0.3% making up all the surface and soil water. Think about that. Every river and lake you've ever seen is just 0.3% of the world's fresh water. It is incredibly limited.
Because liquid water is so crazy scarce, the Earth has to constantly recycle it through the hydrological cycle. It drops down as precipitation, moves across the land as runoff, turns directly from ice to vapor through sublimation, returns to the air via evaporation, and is released by plant leaves through transpiration. It's a continuous, closed loop, literally the planet's life support system. And what does all that water sustain? Biodiversity. Here's another crisp, highly testable definition for you. Biodiversity is the variability among all living organisms. We break it down into 3 levels: genetic diversity within a single species, species diversity across different animals and plants, and ecosystem diversity across varied habitats. Never forget, this incredible variety is the biological engine that keeps the whole system resilient to shocks.
Okay, moving to Section 3, the human disruption.
So now that we understand our resources, we have to look at the human wrecking ball. Our activities are currently clashing hard with biological diversity. Habitat loss is absolutely the single greatest threat, but it's closely followed by the spread of non-native invasive species, overhunting, toxic pollution, and of course the massive overarching stress of global climate change. Let's just say we aren't winning any Roommate of the Year awards on Earth right now.
And we can draw a direct line, a clear cause and effect, between rapid economic growth and this environmental decay. Land and water degradation are directly caused by intensive agriculture, rampant deforestation, mining, the dumping of industrial toxic effluents, and the siltation of rivers. All of these actions drastically reduce the carrying capacity of our environment.
The sheer speed of this disruption is what's truly terrifying. Just look at the jump between 1950 and 1995. In merely 45 years, global coal use more than doubled. Oil production skyrocketed from 518 million tons to nearly 3 billion tons, and the human population itself more than doubled. To put that into perspective, the absolute scale of extraction we're seeing is totally unprecedented in planetary history.
Section 4. Environmental Ethics and Equity.
So how do we actually begin to fix a problem of this magnitude?
Well, it starts with shifting our moral framework. Anthropocentrism is a strictly human-centered view. It values nature only for what we can extract from it. Biocentrism, on the flip side, gives inherent value and rights to all living organisms, regardless of their immediate economic use to us. Grasping this shift is absolutely essential to modern conservation.
And as we rethink ethics, we have to talk about environmental racism. Because the truth is, the burden of pollution doesn't hit everyone equally. Environmental racism refers to discriminatory policymaking that specifically targets low-income or minority communities for toxic waste disposal and heavily polluting industries. True environmental management absolutely requires social equity.
All right, Section 5, Policies for Protection.
Armed with a better ethical framework, how do governments actually protect things? When it comes to biodiversity, examiners love testing this specific distinction. In situ conservation means protecting species directly on site, right in their natural wild habitats, like national parks. Ex situ conservation is off-site, maintaining species artificially in zoos, botanical gardens, or seed banks as a last resort.
But since pollution doesn't stop at a border crossing, international treaties are vital. Here's a quick mnemonic review for your notes. The Basel Convention manages hazardous waste. The Montreal Protocol tackles ozone depletion. The Kyoto Protocol targets greenhouse gases, and the Convention on Biological Diversity aims to halt the extinction of rare species.
But hey, policy isn't just global treaties, it's also local citizens stepping up. Public interest litigation has been incredibly effective. For example, citizen action legally forced the Supreme Court of India to order over 2,000 polluting industries along the Ganga River to either clean up or completely shut down. Similar citizen-led legal actions even protected the soft marble of the iconic Taj Mahal from corrosive industrial emissions. Citizens really do have power.
Finally, Section 6, the path to sustainability.
All the policies and ethics we've covered, they point to one overarching gold standard goal: sustainable development. The definition you absolutely need to memorize is meeting the needs of the present generation without compromising the ability of future generations to meet their own needs. Basically, balancing economic growth with ecological limits. It's the ultimate rule of leaving the campsite better than you found it.
To pull that off, we have to respect the planet's carrying capacity, and there are two distinct types here. Biophysical carrying capacity is the strict, absolute maximum population the Earth's biological resources can physically support. Social carrying capacity is way more complex. It factors in the massive strain added by our modern social consumption habits, energy demands, and global trade.
And that completes our mental map. We've traced the foundations of our ecosystems, the limits of our resources, the massive scale of our disruption, and the frameworks we need to survive it. But the ultimate reality is that the Earth's carrying capacity is strictly finite. So, knowing everything you now know about our planetary limits, what transition will you make today to ensure our survival tomorrow? Thanks so much for watching this explainer, and good luck with your studies.